Have you ever stopped to consider the sheer power of a single action? How about something as seemingly insignificant as the flutter of a butterfly's wings? What if I told you that this delicate movement could, in fact, hold the potential to unleash a cascade of events culminating in a raging hurricane thousands of miles away? This, my friends, is the essence of the butterfly effect, a captivating concept that challenges our very understanding of cause and effect. The butterfly effect is a compelling illustration of chaos theory, a branch of mathematics that delves into the unpredictable nature of complex systems. These systems, like our weather patterns, the stock market, or even our own bodies, are incredibly sensitive to even the slightest changes in their initial conditions. It's like a game of cosmic billiards, where one errant shot can send ripples of consequence across the entire playing field. But fear not, for chaos theory isn't just about impending doom and a universe spiraling out of control. It's about embracing the inherent beauty and interconnectedness of our world, recognizing that even the smallest among us can leave an indelible mark on the grand tapestry of existence. Join me on this exhilarating journey as we unravel the mysteries of the butterfly effect and explore how it shapes our universe in ways both profound and unexpected. We humans have long sought to impose order on the chaos, to find patterns and make predictions about the world around us. We crave certainty, a sense of control over the unfolding narrative of our lives. Yet time and again, the universe reminds us that true randomness is an undeniable force, woven into the very fabric of reality. From the unpredictable dance of subatomic particles to the chaotic churn of galaxies colliding, the universe thrives on a certain degree of uncertainty. Chaos theory doesn't invalidate our scientific understanding, rather it enhances it by acknowledging the limits of our predictive abilities. It's a humbling reminder that despite our best efforts, we may never be able to fully anticipate the future. Think of a leaf falling from a tree, its descent seemingly random, as it's buffeted by even the slightest breeze. Or imagine a single grain of sand shifting on a beach, potentially altering the entire coastline over time. These are but a few examples of how minute variations in initial conditions can lead to vastly different outcomes, making long-term predictions nearly impossible. History itself is replete with examples of the butterfly effect. Moments where seemingly insignificant events have set in motion chains of events that have altered the course of nations and shaped the destinies of millions. Take, for instance, the assassination of Archduke Franz Ferdinand in 1914. This single act of violence, sparked by a wrong turn and a stroke of bad luck, ignited the tinderbox of tensions in Europe, plunging the world into the horrors of World War I. But the butterfly effect isn't confined to the annals of history, it's a constant presence in our daily lives. Consider the chance encounter that leads to a lifelong friendship, or the missed train that opens up an unexpected opportunity. Each day we navigate a complex web of choices and circumstances, never fully grasping how our actions, however small, might reverberate through time. Even in the realm of science and technology, the butterfly effect has profoundly impacted our understanding of the world. The discovery of penicillin, a groundbreaking moment in medical history, was the result of a series of serendipitous events, from a contaminated petri dish to Alexander Fleming's keen observation skills. Without these seemingly insignificant occurrences, the course of medicine and countless lives would have been irrevocably altered. Our journey into the heart of chaos theory begins in the 1960s, with a brilliant meteorologist named Edward Lorenz. Armed with a powerful computer and a thirst for understanding the complexities of weather patterns, Lorenz embarked on a quest that would forever change the way we perceive predictability. Lorenz had built a simplified mathematical model of the atmosphere, hoping to simulate and forecast weather conditions with greater accuracy. One fateful day, in a move that would alter the course of scientific history, Lorenz decided to rerun a previous simulation, this time inputting rounded-off versions of the initial conditions. To his astonishment, the results diverged dramatically from the original run, as if a tiny tremor had amplified into a seismic shift within the digital atmosphere. This unexpected outcome led Lorenz to a profound realization. Even the smallest inaccuracies in measuring initial conditions could have profound and unpredictable consequences on the behavior of complex systems. His groundbreaking work, later dubbed the butterfly effect, revolutionized the field of meteorology and sent shockwaves through the scientific community. At the heart of Lorenz's discovery lay a set of deceptively simple-looking equations now known as the Lorenz attractor. These equations, a testament to the elegance of chaos theory, captured the essence of how small changes in initial conditions could lead to wildly different outcomes in a dynamic system. Imagine a butterfly flapping its wings in Brazil, setting off a chain reaction that ultimately influences the formation of a hurricane in Florida. Lorenz's work challenged the prevailing scientific paradigm of determinism, which held that if we knew the initial state of a system with absolute precision, we could, in theory, predict its future behavior with perfect accuracy. The butterfly effect shattered this illusion of certainty, revealing the inherent limits of our predictive powers when dealing with complex, non-linear systems. The implications of Lorenz's work extended far beyond the realm of weather forecasting. His insights into chaos theory reverberated through fields as diverse as physics, biology, economics, and social sciences, forcing scientists across disciplines to re-evaluate their understanding of cause and effect. The universe, it seemed, was not a clockwork mechanism governed by rigid laws, but rather a fluid, ever-changing tapestry woven from the threads of chance and interconnectedness. One of the most captivating aspects of chaos theory is the paradoxical relationship between randomness and order. While chaotic systems appear unpredictable and inherently random on the surface, beneath the seeming chaos lies a hidden order, a strange attractor that governs the system's long-term behavior. Think of a leaf caught in a turbulent whirlpool. Its path may seem erratic and impossible to predict, yet it remains confined within the boundaries of the swirling water, drawn towards a central point without ever quite reaching it. Similarly, chaotic systems, despite their unpredictable nature, often exhibit patterns and structures that emerge over time. The Lorenz attractor, with its elegant butterfly-shaped trajectory, is a prime example of this strange order within chaos. The system never repeats itself exactly, but its overall behavior remains bounded within a defined region of possibility. This realization opened up new avenues for understanding and even predicting the long-term behavior of complex systems, even in the absence of perfect initial conditions. The butterfly effect, once confined to the realm of theoretical meteorology, quickly spread its wings and took flight across a vast landscape of scientific disciplines. Its impact could be felt in fields as diverse as physics, where it challenged our understanding of turbulence and fluid dynamics, to biology, where it shed light on the intricate interactions within ecosystems. In economics, the butterfly effect underscored the interconnectedness of global markets, where a single event like the collapse of a bank or a sudden shift in investor sentiment could trigger a cascade of consequences, sending shockwaves through the global economy. Even in the realm of human behavior, chaos theory offered a new lens through which to view the complex interplay of individual actions and societal trends. The butterfly effect challenged us to embrace the inherent uncertainty of the universe, to acknowledge the limits of our predictive powers and to appreciate the interconnectedness of all things. It was a humbling yet exhilarating realization, a testament to the boundless wonders of the natural world and the enduring power of scientific inquiry. History is not merely a chronicle of grand events and powerful figures, it's also a testament to the butterfly effect, where small events reshape nations. Take Mohamed Bouazizi, a Tunisian street vendor. In 2010, his act of despair ignited the Arab Spring. Protests spread, toppling dictators in Tunisia, Egypt, and Libya. Similarly, the assassination of Archduke Franz Ferdinand in 1914 plunged Europe into World War I. Small events can ignite a conflagration, altering history. The butterfly effect isn't confined to human affairs, it's a force shaping the natural world. Small changes in ecosystems and weather patterns can have monumental consequences. In a rainforest, a new species can alter food webs and forest structure. Even a harmless vine can become invasive, disrupting the ecosystem. Hurricanes, formed by atmospheric conditions, show nature's raw power. Nature operates on a razor's edge, where small changes ripple through interconnected systems. Our journey into the heart of the butterfly effect takes us to the realm of the very small, where quantum mechanics govern atoms and subatomic particles. In this strange world, chance and uncertainty reign supreme. The butterfly effect takes on a new dimension. Observation can influence a quantum system known as wave function collapse. Measuring a particle can alter its future trajectory. Imagine a photon passing through a slit, becoming a wave of probability. Observation forces it to choose a path, collapsing the wave function. This randomness has profound implications for the butterfly effect. Chance and uncertainty play an integral role. The year 2020 etched itself into human history with the global outbreak of COVID-19, a novel coronavirus that spread rapidly across the globe, bringing life to a standstill and exposing the fragility of our interconnected world. The pandemic, a stark reminder of the interconnectedness of human societies and the unpredictable nature of infectious diseases, serves as a powerful illustration of the butterfly effect in action. The virus, believed to have originated in a wet market in Wuhan, China, quickly spread from person to person, city to city, and continent to continent, facilitated by global travel networks and human-to-human contact. What began as a localized outbreak quickly morphed into a global pandemic, overwhelming healthcare systems, disrupting economies, and forcing billions of people into lockdown. The COVID-19 pandemic underscored the importance of early detection, rapid response, and global cooperation in mitigating the impact of infectious diseases. It also highlighted the interconnectedness of our world, demonstrating how a single event, the emergence of a novel virus in a remote corner of the globe, could have ripple effects that touch the lives of every human being. The butterfly effect isn't just an abstract scientific concept, it's an ever-present force shaping the trajectory of our lives, influencing our relationships, our careers, and our very sense of self. Every day, we make countless decisions, both big and small, that set in motion a chain of consequences, some foreseeable, others entirely unexpected. Think of a chance encounter at a coffee shop that leads to a lifelong friendship, or a missed flight that opens up an unexpected opportunity. These seemingly random events, often attributed to fate or serendipity, can have a profound impact on our lives, shaping our perspectives, influencing our choices, and leading us down paths we never could have imagined. Or consider the ripple effect of our actions on others. A simple act of kindness, like offering a helping hand to a stranger or donating to a worthy cause, can have a positive impact that extends far beyond the initial act. Conversely, a thoughtless word or a selfish act can create negativity and pain that reverberate through our social circles. The butterfly effect invites us to embrace the interconnectedness of our lives, to recognize the potential impact of our actions, however small, and to live with a sense of wonder and possibility, knowing that even the smallest of choices can lead to extraordinary outcomes. The beauty of the butterfly effect lies not only in its poetic imagery, but also in its grounding in rigorous scientific inquiry. Scientists, armed with the tools of chaos theory, have sought to identify the subtle fingerprints of the butterfly effect in realms ranging from the turbulent flows within a fluid to the intricate firing patterns of neurons in the brain. One such quest has led researchers to delve into the heart of turbulence, a ubiquitous yet poorly understood phenomenon that governs everything from the flow of air over an airplane wing to the churning of blood within our arteries. Chaos theory has provided a new lens through which to view this chaotic dance, revealing hidden patterns and structures within the seemingly unpredictable flow. Imagine, if you will, a simple yet captivating contraption known as the double pendulum. Two rods connected by a hinge swing freely, their movements governed by the fundamental laws of physics, gravity, inertia, and momentum. At first glance, the double pendulum's behavior seems predictable. It swings following a regular rhythmic pattern. However, as we observe the pendulum for extended periods, something remarkable occurs. The swings, initially predictable, become increasingly erratic, their trajectories diverging wildly with each passing moment. Even with a precise understanding of the laws governing its motion and accurate measurements of its initial conditions, we find ourselves unable to predict the pendulum's trajectory beyond a certain point. For centuries, humans have gazed up at the sky, seeking to decipher the capricious whims of the weather. From simple weather vanes to sophisticated satellite imagery, we've strived to predict the unpredictable, to anticipate the fury of storms and the gentle caress of a summer breeze. The advent of chaos theory and its application to meteorology, pioneered by Edward Lorenz, revolutionized our understanding of weather forecasting. Scientists realized that the atmosphere, far from being a predictable machine, behaved more like a giant interconnected fluid, exquisitely sensitive to even the slightest perturbations. These models, however, remained fundamentally limited by the butterfly effect. Even with precise measurements of current weather conditions, the inherent uncertainties in our observations, those tiny tremors in the data, inevitably amplified over time, placing fundamental limits on our ability to make accurate long-range weather predictions. Ensemble forecasting, a technique that involves running multiple simulations with slightly different initial conditions, emerged as a powerful tool for quantifying uncertainty and providing a range of possible weather outcomes. Our exploration of the butterfly effect leads us now to the frontiers of physics, where the bizarre and often counterintuitive laws of quantum mechanics hold sway. Here, in the realm of the very small, where particles behave like waves and uncertainty reigns supreme, the butterfly effect takes on a whole new dimension. Quantum mechanics, with its probabilistic nature, throws a wrench into the classical view of determinism. At the atomic and subatomic levels, we can no longer speak of precise trajectories or predict with absolute certainty the outcome of an experiment. Instead, we are left with probability distributions, clouds of possibility that govern the behavior of particles, even if we possessed perfect knowledge of the initial conditions of a system, down to the position and momentum of every single particle. Quantum uncertainty would still inject an element of randomness into its evolution. This realization opens up exciting new avenues for exploration, challenging us to re-examine our assumptions about the nature of reality and the limits of human knowledge. For decades, economists have sought to model the complexities of the market, striving to predict the ebb and flow of financial tides, the booms and busts that shape our economic landscape. The butterfly effect, with its emphasis on sensitivity to initial conditions and the interconnectedness of complex systems, offers a compelling framework for understanding the inherent unpredictability of the market. Consider the collapse of Lehman Brothers in 2008. A pivotal event that triggered a global financial crisis. The Lehman Brothers collapse serves as a stark reminder of the interconnectedness of our globalized economy and the inherent difficulty in predicting the consequences of even seemingly isolated economic events. The butterfly effect isn't confined to the realms of finance and meteorology. It also has profound implications for our understanding of health and well-being. Consider the rise of obesity and chronic diseases like type 2 diabetes and heart disease in many parts of the world. These health challenges, once relatively rare, have now reached epidemic proportions, driven by a complex interplay of factors including changes in diet, physical activity levels, and our social and built environments. The rise of fast food restaurants, the proliferation of sugary drinks, and the decline in physically demanding jobs have all contributed to an environment where unhealthy choices are often the easiest and most affordable. The butterfly effect challenges us to view health through a wider lens, recognizing the interconnectedness of our physical, social, and environmental well-being. As we grapple with the challenges of climate change and biodiversity loss, the butterfly effect takes on a new urgency, reminding us of the interconnectedness of our planet's ecosystems and the potential for even seemingly small disruptions to have far-reaching consequences. Consider the delicate balance of a coral reef ecosystem. Even a slight increase in ocean temperatures driven by climate change can trigger coral bleaching, a phenomenon where corals expel their symbiotic algae, turning a once vibrant reef into a ghostly white skeleton. The butterfly effect challenges us to view conservation through a lens of interconnectedness, recognizing that protecting our planet's biodiversity requires a holistic approach that addresses the root causes of environmental degradation. Embracing the flutter, living in a world shaped by butterflies. The butterfly effect invites us to embrace the inherent beauty and complexity of our world, to acknowledge the interconnectedness of all things, and to recognize the potential for even the smallest of actions to have far-reaching consequences. It's a call to live with a sense of wonder and possibility, to appreciate the intricate web of cause and effect that shapes our lives and the world around us. Live with intention, knowing that even the smallest acts of kindness, courage, or creativity can ripple outward, creating a more beautiful and compassionate world. As we reach the end of our exploration, the delicate but persistent echo of a butterfly's flutter lingers in our minds. We've journeyed from the swirling heart of a hurricane to the intricate dance of a double pendulum, from the bustling floor of a stock exchange to the quiet laboratories where scientists grapple with the mysteries of quantum mechanics. The butterfly effect, once a niche concept in the realm of meteorology, has taken flight, its wings spanning across countless disciplines, challenging our assumptions and deepening our understanding of the world around us. It's within this embrace of uncertainty, this acknowledgement of the limits of our predictive powers, that we find a new kind of liberation, a freedom to explore the vast and unknown territories of our universe with a sense of wonder and humility. The butterfly effect challenges us to let go of the illusion of control, to embrace the reality that we live in a universe in a state of constant flux, where change is the only constant. We can no longer cling to the notion that we can predict and control every aspect of our lives or the world around us. Instead, we're invited to adopt a stance of mindful engagement, to acknowledge the interconnectedness of our actions and to navigate the complexities of our world with a blend of wisdom, humility, and a healthy respect for the unknown. We can still set goals, make plans, and strive to create positive change in our lives and the world around us, understanding that our best laid plans are always subject to the whims of fate. The butterfly effect, while challenging our notions of predictability and control, also opens our eyes to the inherent beauty and wonder of a universe in constant flux. It's in the unexpected encounters, the serendipitous discoveries, the seemingly random events that redirect our paths, that life's most extraordinary adventures often unfold. The butterfly effect reminds us that the universe is a place of infinite possibilities, where even the smallest actions can ripple outward, creating a cascade of consequences that shape the grand tapestry of existence. It's an invitation to embrace the unknown, to find joy in the unexpected, and to approach life with a sense of curiosity and openness to new experiences. Perhaps one of the most empowering messages embedded within the butterfly effect is the realization that even seemingly small actions can have a profound impact on the world around us. Just as a single butterfly's wings can influence the weather, so too can our individual choices and actions ripple outward, creating a cascade of consequences that shape the world we live in. This understanding can be both humbling and inspiring. It's an invitation to live with intention, to choose kindness over indifference, to act with courage in the face of injustice, and to use our voices and actions to create a more just, compassionate, and sustainable world. As we conclude our exploration of the butterfly effect, we're left with a profound sense of interconnectedness, a recognition that our lives are inextricably linked to the lives of others, to the fate of our planet, and to the vast web of life that sustains us.